The conservation of matter in a cycle of chemical reactions consists of a cycle of reactions which objective is to prove that matter conservation. To start the experiment, we have the metallic copper with a series of reactions. We obtain different compounds, and in the end of the cycle we regain metallic copper and it should weigh the same as the beginning. The important part is to prevent the loss of any product or byproduct during the reaction cycle and that the reactions are made in order and with established amounts in the experiment. We like it because the fact that copper after being transformed it could return to metallic state and with this can be observed with the law of conservation of matter.
The electrolysis of an inorganic salt and electrorefining of copper consists of two experiments, where an electric current is used to create a chemical reaction. The electrolysis experiment creates a redox reaction where potassium hydroxide and iodine was formed, and in the other experiment one cell of copper was dissolved and then it formed again in the other cell. The important parts of these experiments are how to identify the cathode and the anode, understand the reactions that are taking part of the experiment, and how the current affects it. We like it because it involves electricity in a redox reaction, and also electrorefining is an industrial process for the manipulation of copper.
Galvanic cells and corrosion. The experiment consists in making a galvanic cell with different compounds to observe how the redox reaction becomes spontaneous, creating a flow of electrons, and observing how different galvanic cells create different voltage. The important parts of these experiments were to use a salt bridge to permit the flow of ions from one container to the other. Other important part was that we need to check the voltages in the correct order and to know what reaction were occurring. We like this experiment because we understand now how a battery functions and also because these kind of things are in our daily life, like in our computers, cell phones, and other electric components.